Hello, welcome back to my recorded classes. Today we are discussing the topic from module 3, 3.1 sets and set operations. So let's start the topic. So before starting the content, all of you please subscribe my channel for getting new recorded classes from this course. Okay, so let's start. First we will see what are the topic and subtopics from this module. Module 3 actually fundamental structures. First section sets and set operations, and second section we are discussing about the functions, and third section sequences and summations. Okay, so these are the three sections in this module. So let's start the first section, 3.1 section, set and set operations. So before starting module 3, actually what are the main applications you can see here? Sets, these ideas, sets, functions and sequence, summation, these ideas mainly concentrating, mainly using here in SQL, structured query language. Okay, this topic more using the set ideas, and same way in the civil engineering field many functions we are using, or the construction field or different shapes we are using, and same way some analysis purpose, data analysis, demand function, and the same consumer expenditure, many things we can graphically represent by using some function, and we can analyze like exponentially increasing, decreasing, like many things we can conclude from that one. Okay, so let's start the first section, 3.1 sets and set operations. So first I will give some outline, and after that we will do some questions from each subtopics. So we will go to the first one. What is the meaning of set? Set means it is a well-defined collection of objects. Set means a well-defined collection of objects. For example, see here some examples given. Example 1, set of all vowels in English alphabet. Okay, all of you know the vowels in English alphabet. A, E, I, O, U. These 5 letters, correct? A, E, I, O, U letter. So set of all vowels in English alphabet, it is a set, correct? It is well defined collection of object. A is the first member, A is a member, E is a member, I is a member, O is a member, and U also a member of that set, correct? Now set of all even number. Even number means 2, 4, 6, 8, like that it is continuing, correct? Even numbers. So this is also a well defined collection of object or numbers. So this is also a set. Okay, so we can see what are the members in that even number set. 2, 4, then 6, then 8, then 10, like that the members, that are the elements of the set, correct? Now sets are usually denoted by capital English letters. We can name to the set as by capital letters, capital English letters. For example, A equal to, correct? A equal to, as I told you, for example, we are taking odd numbers set. Okay, set of all odd numbers. Okay, odd numbers we are taking means 1, we are taking 3, 5, 7, like that it is continuing, correct? Many numbers we can write, odd numbers. Okay, now sets always, as I told you, we are representing by using capital letters. Capital A equal to, this is the set, correct? And set we are representing the elements of the set, we are represented by small letters A, B, C, or numbers, etc., correct? We can use the numbers or some A, B, C, like small letters we can use, or etc., some other things also. Now elements of a set which are surrounded by 2 curly bracket, okay, and separated by commas. See, you can see that one. Set always we are representing by using the curly bracket, by using this bracket. Inside we are writing the numbers one by one, first number here, okay, and then putting comma, write next number, then comma, next number, like that we are representing in a set. Okay, so representing set by using curly bracket we are using, or this type of bracket we are using. Now another point we need to know that what is the meaning of this symbol, what is the meaning of this symbol, element of or belonging to. Okay, if a number is belonging to a set, we can use this symbol. For example, this odd number set, 1 is an element of that set, correct? So we can write 1 belongs to the set A, correct? Because 1 is a member of that set. Same way 5 or 3 is a member of that set, correct? 3 is belongs to that set A. 5 is a member of that set. 5 belongs to that set, we can say. Now, for example, another one, 2. Number 2 is not a member of that set. So that time we are using the symbol doesn't belongs to, that crossing that symbol, correct? So 2 is doesn't belongs to the set A, we can say that one. So two symbols here we are telling, one is belongs to A belongs to A means A is a member of that set. And the sign A doesn't belongs to A means indicate that A is not a member of that set, okay? Not a member of that set. Now, as I told you, okay, now before example, set of all vowels in English alphabet, correct? Set of all vowels in English alphabet. How many letters are there? 5 letters are there, okay? Correct? If I am writing like this, okay, set of all vowels. So I am representing by B here. For example, B equals, okay, what are the elements? A, E, I, O and U, correct? A, E, I, O, U. These are the vowels. How many letters are there inside this set? 5 letters are there, correct? That means the number of elements of B, I can represent like this, n of B, number of elements of the set B equal to 5. Or we can say, we can use this symbol also, cardinality of the set B equal to 5. So one of the symbol we can use for representing how many numbers are there or how many elements are there in the set. Either we can use the symbol n symbol, n of B. N of B means number of elements of B equal to 5. Otherwise, we are using this absolute symbol, cardinality of the set or number of elements of the set B equal to 5. That is the next point here. Cardinality of a set, absolute of S or cardinality of S we are calling, or n of S, number of elements of the set S, represents the cardinality of the set or size of the set, okay? Cardinality or size of the set. Size of the set means how many numbers are there, how many elements are there in the set, okay, is called the number of distinct element, okay? Just keep in your mind distinct element, okay? Only we are choosing the distinct, separate elements in the set. So I hope you understood these points, how we are representing a set, capital letters, and inside numbers we are representing small letters or numbers, and set always we are using the curly bracket, and belongs to A means that number should be inside that set, and doesn't belongs to means number doesn't belongs to that set, and cardinality or number of elements of a set means we are representing number of S or number of elements of a set B, or we can use this symbol also, okay? I hope you understood the first meaning. Now we will come to the next meaning, representation of a set. How can we represent a set? Okay, so before coming to the representation of set, you can see some of the set I am written here. Natural numbers, correct? Natural numbers means the counting numbers. We are representing the capital N symbol. N means 1, 2, 3. It is going like that, okay? I can write here the natural number, correct? Natural number means the counting numbers, okay? Natural numbers we are using the letter capital N. The set is 1, 2, 3, 4, 5, 6, like that it is continuing. Now integer set, okay? Integer means we are representing by using capital Z. Capital Z means what we are taking, natural numbers 1, 2, 3, 4, 5, and its negative part -1, -2, -3, -4, these numbers, and 0 also included. This number full we are calling integer numbers. That means 0, 1, 2, 3 going like that, -1, -2, -3 going like this, 0 also included, okay? Integer numbers. Now if you are representing Z plus means only positive integer, only positive number. That means what are the numbers? 1, 2, 3, 4, 5, 6, like this, correct? That means only positive part, 0 is not included, only positive part. Z minus means only the negative number part, correct? So what are the number? -1, -2, -3, -4, -5, these numbers. Okay, so z plus means only positive integers, z minus means only negative integers we are choosing. Now another set of the numbers. So integer we are discussed. Now next number is rational number. Rational numbers we are representing by using the letter Q letter. Okay, Q means the rational numbers. So rational numbers means a number of the form P by Q, correct? P by Q form. P and Q are integer numbers. So P by Q, for example, we can write like 1 over 2, correct? Or we can write like 2 over 3. Okay, many numbers we can write like numerator by denominator, this form. Okay, very simple example I am telling. Already we are discussed that all in class. So 2 by 3, 1 over 2, or 5 over 7, like these terms we are calling rational numbers. Now lastly, real numbers. Okay, real number system. Real numbers means all the number system, including all these numbers, rational number, irrational number, integers, natural number, all the number. Okay, that we are calling capital R, set of all real number, all the number under consideration. Okay, all the numbers. Okay, that is what we are calling the real numbers. That means 1, 2, 3, 4, 5, 1.1, 1.2, 1.3, -1.1, any number if you are choosing root 2 or 1 by 2, all the numbers we are calling the real numbers, set of all real numbers. So the basic number system, okay, this is you are studied before, we are using here while doing the questions. Okay, now come to here. So just remember this number system. Now how to represent a set? Representation of set. Okay, representation of set. Now for representing set, there are two ways for representing the set. One is the roster form or listing the numbers. Okay, listing method or roster method. Okay, listing method. Okay, listing method or roster method. And second one is set builder method. Okay, set builder method. So what are the meaning of this one? You can see. Okay, one is the roster method, second one is the set builder method. For example, see set builder method, you can see E equal to set of all x such that x is an even number 5 less than x less than 13. Okay, I can show to you in another page. For example, set builder. Okay, builder method, and the first one is roster method. Okay, roster method. Okay, now we will discuss these two here, roster method and set builder method. First example we will consider set of all x such that I will write here the set of all x. Whenever we are writing set builder method, we are starting like this: set of all x, set of all numbers such that, this line means such that x is an even number. Okay, x is an even number, and what is the condition here? You can see x is an even number, comma 5 less than x less than 13. Okay, 5 less than x less than 13. So you can see what is the meaning of this one. Okay, I will show this example. Later example you can see from there. For example here, set builder method. So what are the number? X is an even number. You know what is the meaning of even number, correct? 2, 4, 6, 8, correct? Then 10, then 12, then 14, then 16, like that it is continuing, correct? Set of all even number. Even number, then x should be what in range? 5 less than x less than 13. That means starting from 5 number and ending at 13. Okay, starting 5. That means in between 5 and 13, what are the even number? That we need to write here. Okay, starting from 5. 5 is not included because you can see 5 less than. If it is equal to means that number also we can consider. Anyway, 5 is not an even number, so there is no confusion here. Okay, so there is no equal. So less than 13 also. So 5 to 13, in between what are the even number? Okay, that is the meaning of this set. So what are the number you can see here? Okay, 6 is an even number after 5. Okay, so 6, 8, then 10, then 12, correct? 14 we cannot consider because up to 13 maximum, correct? But 13 is odd number, so nothing to worry. So 6, 8, 10 and 12, these are the number. So if we are writing this number directly by using the numbers, okay, for example 6, that is 8, then 10, then 12. If we are writing like this, okay, this is what we are calling roster method. Roster method, that means the listing method, okay, listing method. That means the number we are listing one by one. That is why we are calling the listing method. So set builder method, we are not writing all the number. We are just writing the form of the number. See, set of all x such that x is an even number, 5 less than x less than 13. That representation we are calling set builder method. Just building only that set. But if you are writing that set like this, all the number if you are writing like this, that is we are calling the roster method or listing method. I hope you understood this example, how we are writing in set builder method and how we are writing the numbers in roster method. Now we can come back to this example. See, now second example we can see n equal to, capital N equal to set of all x, set of all numbers such that x is a natural number. X is a natural number. Natural number means just now I told you what are the natural number, 1, 2, 3, 4, 5, like that going, correct? So I am written here that set here, n equal to 1, 2, 3, 4, 5, 6, like that the number. Now the third example we can see v, capital V equal to set of all x such that x is a vowel in the word potatoes. Okay, so potatoes, this word, what are the vowels? What letters are the vowel? That letter only write. That is the meaning, set of all x such that x is a vowel in the word potatoes. So for example we can see, you know what are the vowels? A, E, I, O, U, correct? So here one vowel A is there, okay, then we can come to O is there here. See, this letter O is a vowel and E is a vowel. So what are the vowels coming? A, E and O. Each letter we can write only one time. See, A is a vowel, E is a vowel, O is a vowel. O is coming 2 times, but write only one time. Okay, this set. So that is the listing method or roster method representing the set builder form. Okay. Now same way the last example you can see O equals set of all x such that x is a odd positive integers. Odd number should be. Okay, odd number, positive number, less than 6. So less than 6, what are the odd numbers we can see? Less than 6. Below 6, what are the odd numbers? Only positive number, correct? So what are the odd numbers less than 6? 1, 3 and 5, correct? You can write like this, 1, 3 and 5. See, here I am written 5, 1, 3 because in set writing order there is no importance. You can write 5 first or 3 first or 1 first. There is no importance in the order. But you can write all the number there. Order there is no importance. So what is the answer? 5, 1, 3 or 1, 3, 5. That are the elements in that set. So these are the two representation of a set. One is the set builder method and second one is the roster method. Now we will do some question from here. After that we will go to the next topic. Okay. So let me start the exercise here. So what are the things we discussed now? We are doing that questions here first. Exercise 3.1. Okay. Question number 1. Exercise 3.1. Question number 1. So what is the question? Represent the following sets by using listing method or roster method. Okay. So set builder form is given. Write that set into the listing method or roster method. Okay. Represent that by using listing method or roster method. For example, first example, set of all x such that x belongs to R. That means x is a real number. X belongs to R means x is a real number. Such that x square should be 1. Square of that number should be 1. So what are the numbers we can write? Okay, set of all real numbers such that square of that number equal to 1 should be equal to 1. So what are the numbers we can write? So if you want to find the number square of a number equal to 1 means you can see this one, x square equal to 1. X square equals 1. So from this you know how to find x. X equal to plus or minus root 1, correct? Because square we are deleting. So what are the numbers we are getting? Plus or minus root 1 means 1. So what are the answer? Two number, x equal to plus 1, x equal to minus 1, because plus 1 square is 1, minus 1 square also 1. Square of a number should be 1. So what are the numbers? Okay. So answer I am writing here equals set of all, what are the numbers? 1 and minus 1. I hope you understood the question. What are the numbers coming? Okay. Now we will go to the second question. Okay, so B part of the question, we can see set of all x such that x belongs to z plus. Z plus means, what is the set z plus? Z plus means positive integer, correct? So what are the positive integers? You can see 1, 2, 3, 4, 5, 6, 7, 8, correct? 9, 10, 11, 12, 13, 14, like that it is going, correct? Positive, only positive integer number. Now what is our question? Set of all x belongs to z plus. So should be a positive integer. Such that z topside plus means positive integer. Z means integer, topside plus means positive integer. Such that x should be below 12, less than 12. 12 is not included. Below 12, what are the positive integers? So you can say the answer directly. What are the numbers? 1, 2, 3, 4, 5, 6, up to which number we are writing? To 11, correct? Because 12 not included, so up to 11. So that is the answer, set 1, 2, 3 up to 11. I hope you understood the question. Now question number C, set of all x such that x belongs to n and such that x square should be less than 100. X should be a natural number. Okay, I will show here in the next page. X belongs to n, correct? X belongs to n means what are the natural numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, like this going, correct? Now what is the condition we need to check? Such that x square should be less than 100. Square of the number should be less than 100. Okay, x square should be less than 100. For example, you can see, okay, for example, this is x number. First, x belongs to n means x is a natural number. X1, if you are taking, what is the square of this number? X square, 1 itself, correct? Now if you are taking 2, what is the square of this number? 4. 3, what is the square? 9. 4 square is 16. 5 square is 25. And 6 square is 36. 7, what is the square of that number? 49. 8 square 64. 9 square is 81. 10, what is the square of the number? That is 100, correct? Square of the number 10 means 100, correct? Now square of 11 means 121. 121, like that it is going. I am not writing all the numbers. Now what is our condition, our question? Square of that number should be less than 100. What are the numbers? Square of that number should be below 100. 100 is not included because less than 100. If it is equal means 100 is included, but less than only. So less than 100, what are the square number? For example, 9 square, 81 only. 100, 10 square is 100, we cannot take. So this number we can take, this one we can take, these numbers we can take. So what are the numbers? We are getting the answer 1, 2, 3, 4, 5, 6, 7, 8 and 9. Up to 9 when we are taking the square below 100. Square of that number is below 100, correct? 10 and above, if you are taking, square will be more than 100. So below 100 square, what are the numbers? So I am writing the answer here. What are the numbers writing? Set 1, 2, 3, 4, 5, 6 up to 9. I hope you understood the question, correct? Now next one, we will do the next question. Set of all x such that x is a solution of the equation x power 2 plus x minus 2 equal to 0. So what are the solutions of this equation? What is the equation here? X power 2 plus x minus 2 equal to 0. Okay, just to find the solution of this equation, you can use the calculator. You can press the mode button. After that you can press equation. Equation is number 5. Okay, after that we can go to the number 3, ax power 2 plus bx plus c, number 3. Okay, because here power 2 equation, x power 2, correct. Then apply what is a number. A number means x power 2 behind number here, that is 1, press equal to. B means x behind number, that is 1, press equal to. After that c number, constant number, minus 2, then press equal to. You will get what are the solutions. Okay, so what are the solutions getting? X equals 1 and second one x equal to minus 2. Hope you understood. X equal to 1 and x equal to minus 2 there. So these are the two numbers, correct. So we can write the answer here. So what are the numbers? 1 comma minus 2. Solutions of the equation x power 2 plus x and minus 2. So I hope you understood that question. Now we are going to the next one. Set of all x such that x is a letter in the word priority. X is a letter in the word priority. So this word priority, what are the letters in the word priority? For example, P. P is a letter, correct. R is a letter. I is a letter, correct. O is a letter. Then again R no need to write, R no need to repeat that one, okay, R one time. So O, after that I also repeating, no need. T is a letter and Y is a letter. So this is the letters of the word, letter in the word priority, correct. Hope you understood how to write the set in the listing method, okay, or the roster method. Now we will go to the next question, question number 2. Use the set builder notation. Okay, use the set builder notation, the second representation, to describe the nature of the each of the set. Set builder notation we need to write. Okay, use the set builder notation to describe the nature of the following sets. For example, first one, 3, 6, 9, 12, correct. Think about that number. How can we write that number? Now, whenever you are starting set builder method, you can start with set of all x such that. Now, what are the other condition we need to write? So, first number 3. You can see that number 1 multiply 3, that is 3, correct. Then 2 multiply 3, that is 6. 3 multiply 3, what is that one? 9. Then 4 multiply 3, that means 12, correct. So what is the mean by that number order actually? It is a multiple of 3, correct. See here 3, 1 multiply 3, 2 multiply 3, 3 multiply 3, 4 multiply 3 means it is just a multiple of the number 3, correct. So what we can write the condition? Set of all x such that x is a multiple of 3. Multiple of 3, correct. And you can write from where to where is the multiple? 3 less than or equal to x less than or equal to 12. In between 3 and 12, what are the multiples of the number 3, correct. 3 also included, 12 also included, 3 included, because I am using here equal to symbol also. This is the easier way. Okay, you can write another way also, but this is the easier way. X is a multiple of 3 and comma 3 less than or equal to x less than or equal to 12. So that is the first question. Okay, just identify that number. Think yourself and identify the number. What is the order of that number, importance of that number? Multiple of 3. So we can write set of all x such that x is a multiple of 3, 3 less than or equal to x less than or equal to 12, starting from 3 ending at 12. In between, what are the numbers? Including 3 and 12. Okay, now let me go to the next one. Minus 3, minus 2, minus 1, 0, 1, 2, 3. Okay, these numbers. So we will go to this one now. Minus 3, minus 2, minus 1, 0, 1, 2, 3. What type of numbers this one? Integers, correct. So we can write the answer set of all x such that x belongs to which set? That one? Integer set, correct. So x is an integer, z letter. Z letter means integer number. Now from where it is starting? Minus 3 less than or equal to x less than or equal to 3. Starting from minus 3 to 3, correct? Minus 3 starting and ending at 3. So what are the integers in between, including that numbers? That is that set, correct? Minus 3, minus 2, minus 1, 0, 1, 2, 3, like that. Okay, now let me go to the third question now. Hope you understood. So third question, 1, 2, 3, 4, 6, 12. What is the importance of this number? What type of number this one? 1, 2, 3, 4, 6 and 12, correct? So think about that number. What is the meaning? See, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Most of you understood already that number. What is that one? Now, when we are taking this number, see, 12 is the bigger number, maximum number, correct? Now, think about this number 12. For example, 12 divided by 1. It is possible, correct? That means 1 is a divisor of the number 12. Divisor, correct? I am using the idea divisor. 1 is a divisor of the number 12. Now 12 by 2 we can do, correct? So 2 is a divisor. 12 by 3 is possible. We can divide. So 3 is a divisor. 12 divided by 4 is possible. So 4 is a divisor. But 12 divided by 5 is not possible, correct? We are getting point number. Okay, so not a divisor. 5 is not a divisor. 6 is possible. 12 divided by 6 is possible because it is a divisor. 12 by 7 not possible. 12 by 8 not possible. 9 not possible. 10 not. 11 not possible. But 12 by 12 is possible because any number divisor of itself, correct? 12. So that are the number given here. See, 1, 2, 3, 4, 6 and 12. So how can we write this as the set builder form? Equal to set of all x such that x is a divisor. X is a divisor of the number 12. X is a divisor of the number 12. 12, we have what are the divisors? 1, 2, 3, 4, 5, 6 and 12. So x is a divisor of number 12. No need to write any range because only the number 12, these are the divisors, correct? So this is the idea in the set builder notation. I hope you understood this one. Okay, now let me go to the another idea. Types of sets. Okay, the sets we can classify many types. First we are calling empty set or null set. Empty means nothing, empty set, correct? We are representing either by using phi notation or this simply a set notation, blank, inside nothing is there, correct? So either we can use this symbol, phi symbol, or we can use the blank like this set, okay, empty set or null set. Null set means nothing, a set has no elements in it, okay, inside nothing. For example, see one example also here, set of all x such that x is a natural number. X should be a natural number and 2 less than x less than 3. In between 2 and 3. Is there any natural number in between 2 and 3? Nothing. 2 is a natural number, 3 is a natural number. But in between 2 and 3, 2 and 3 are not included. There is no natural number, correct? So what is the set actually this one? This is empty set. Nothing, correct? Phi actually. So this is one example of the empty set. Set of all natural number. From 2 to 3 there is no number, so empty set we are getting. So like that set we are calling empty set or null set. Now singleton set, next one, singleton. Single means one. So singleton set means a set with only one element in it. Okay, for example set 7. Set 7 means it is a singleton set because only one number. Now finite set. Finite set means a set consists of definite number of elements. That means we can count how many numbers are there. Okay, 4 number, 5 number, 6 number, 7 number, like that, finite number, correct? For example, set 6, 8, 10, 12, correct? 6, 8, 10, 12. How many numbers are there? 4 numbers. That means the cardinality of E equal to 4 or number of elements of E equal to 4. So number of elements of that set is finite, just a countable number. 3, 4, 5, 6, 7, 8, 9, any number like that. Okay, we can count how many numbers are there. So like that set we are calling finite set. Okay, now infinite set. What is the meaning of infinite set? You can see a set which is not finite. A set which is not finite. That means infinite number of elements are there. Infinite, correct? Infinite number of elements are there. For example, n. 1, 2, 3, 4, 5, 6, 7, 8, 9. Infinite number of elements are there. So, this is the infinite set. We cannot count the correct number. How many elements are there inside? Infinite number. So, that is infinite set. Now, equal set. What is the meaning of equal set? Two sets are said to be equal. Okay, if they have same elements. Okay, if and only if they have same elements. For example, A equal to 139. A equal to set 139. B equal to 913. You can see these two sets are equal set. Why? Because 139. 1 here also there. 3 here also there. 9 here also there. Same number of same elements in both set. Correct? Order is different. So in set order there is no importance in the order. You understood? You can write the order number in different order. So 139 and 913 are equal sets. Now again we can see another example. This set A 025, B 052552 are equal sets. Why? Because 0 is a number here. Correct? 2 also here, but it is coming 2 times. No problem. But still it is same only, equal set only. 5 here it is there. Here also 5 is there, but coming 3 times. But no problem. These two sets are equal because same elements in both set. 1 is 0 is there, 2 is there, 5 is there. Another set also same number. Same elements. Not same number, same elements are there. So these are the equal sets. I hope you understood the definition of equal set. Okay, now we are going to another definition, subset. What is the meaning of subset? Okay, so subset means a set is a subset of another set B. Every elements of A is also an element of B. Okay, for example, you can see this set A 2, 4, 8. What are the numbers in set A? 2, 4 and 8. Now we can see another set 2, 4, 6, 8. 2, 4, 6, 8. Okay, I can show here. A set is set 2, 4 and 8. Another set B. B set equal to 2, 4, 6, 8. 2, 4, 6 and 8. Okay. Now you can see what is the meaning subset. All the elements of A. For example 2. It is already here. 4 also here. 8 also here. Correct. So all the members of A is also belongs to the set B. Then we can say A is a subset. We are using this notation, subset symbol. Okay, so A is a subset of B. We can write like this: A is subset of the set B. That means A is the smaller set, B is the bigger set. All the elements of A coming in B set. Okay, A subset of B. So that is the meaning A subset of B. Now A subset of B, if A belongs to A belongs to B also it should be. It is the proper subset or proper subset we can say. Now A subset, and you can see an equal to symbol, correct? That means that either A contained within B or A is identical to the set B. For example, we can see set 1, 2, 3, correct? And another one also set 1, 2, 3, correct? So all the elements of the first set also same as second set. So that time we can use this equal to symbol. Okay, subset itself, same set is subset of itself. Now you can see another example. Set 1, 2, 3, 8 is not a subset of Q. Why is not a subset? 1 is coming in the second set, 2 also there, but 3. See, 3 is coming here, but 3 is not here. So this P we cannot write. It is not a subset of Q, correct? So P is not a subset of Q, that one. All the elements should be a member of the second set. I hope you understood. Now, whenever we are taking a set, phi is a subset of all the set. That means the empty set. Empty set should be a subset of all the set. And the same set, S is a subset of itself. All the set are subset of itself. We can write S subset of itself. Understood? So any set we are considering, that time we can write two subset easily. Phi is a subset of all the set and same set is a subset of itself. So these two ideas keep in your mind. Now we will go to another one. power set. What is the meaning of power set? Power set of a set S is set of all subset. Set of all subset we can call the power set of S. We are denoting by P of S, power set of S. P means the power set of the set S. For example, see S equal to 0, 2, 4. This is the set. How many numbers are there? Number of elements of S equal to 3, correct? Now, write all the subset of this set. So, what we will do, we can just write, I will show here, okay, set 0, 2, 4. This is the set S, okay. Now, power set of S, P of S, power set of S equal to, just to use the set notation. Now, inside the set notation, write all the subset of the set. First, write phi. Phi is a subset of all the set, first member. Secondly, we write the singleton set, one number set. For example, set 0 is a subset. Set 2 is a subset. Set 4 is a subset, correct? And then you write two number set. 0, 2 is a subset. 0, 4 is a subset. 2, 4 is a subset, correct? 2, 4 also a subset. Don't write 2, 0, 4, 2 like that. Okay, set number order is there is no importance. So 0, 2, 0, 4, 2, 4. Only two numbers subset. Now, lastly, the same set itself is subset. 0, 2, 4. Okay. Now this collection, this set, okay, this total set. How many elements are there in this power set? Okay, this is 1, 2, 3, 4, 5, 6, 7, 8. Correct? This 8 subset collection we are calling the power set of the set S. So how can we find how many elements are there in the power set? Just to use, okay, just to use number of elements of P of S. Power set of S means in power set how many elements are there means 2 power number of elements in that set. Okay, 2 power number of elements in this set. For example, here 2 power, how many elements are there in the set S? Number of elements of S means 3, correct? So 2 power 3, what is 2 power 3? 8. So you will get 8 elements in the power set. 8 elements in the power set. You can see what are the 8 elements here. This is the first element, second one, third, this is 4, okay, 5, this is sixth one, this is seventh one, and this is the 8th one. 8 subset are there. That collection we are calling power set. So 2 power number of elements of the set. That many subset will be there, or that many elements will be there in the power set. So I hope you understood that example. Okay, now you can note here a set having n elements. Then the power set of A has 2 power n elements, or 2 power number of elements of the set. For example, cardinality of A equal to 3, number of elements of A equal to 3. Then cardinality of power set. Okay, you can use the absolute symbol as I told you, or number of elements of P of A equal 2 power 3 equal to 8 elements. So hope you understood what is the meaning power set. Now we will go to the next category, universal set. Universal set means like real numbers. All the universal set means a set which contain all the object under consideration, denoted by U. Okay, U means the universal set, all the elements under consideration. That is what we are calling universal set. For example, set of real numbers is the universal set of all real numbers in the real system. Okay, capital R, because all the numbers are there in the real number system. Natural number, integers, rational number, irrational number, all the number collection together, correct, the real number. So that real number system we can call universal set in the real system. Same like that, all the elements under consideration, that is what we are calling universal set. I hope you understood. Now we will go to the next point, that is the Venn diagram. How can we represent a set by a diagram? That diagram we are calling Venn diagram. So in Venn diagram, universal set, this is the bigger set, correct? Always we are using rectangle for representing. See, I used here one rectangle. This is the bigger set, universal set. Okay, then subset, the subset of the universal set we are representing by using circles, or we can use geometric shapes like the triangle or rectangle like this, or elliptical symbol like, okay. So for example here see, A is a subset, okay, elliptical symbol or circle symbol you can use. B is a subset, correct. B is a subset of the universal set. A is a subset, B is a two subsets are there, correct. A subset of the universal set, B subset of the universal set here. Also A subset of B, correct. A subset of B, because all the elements of A belongs to the B, correct. Complete A belongs to B. So A subset of B also here. So subset always representing by circle or other geometrical shape. Circle is usual. Now elements of a set is denoted by point. For example, if I am writing a point here, you can just use a point, dot 5. That means 5 is a member of universal set, correct. Now if I am writing one number here, 2, one point you can put, just mark that number, that is the meaning point. So 2 is a member of the A set. Same 2 is a member of B set also, because A is coming inside B, correct. For example, now if I am writing here 7 is a member of which set? B set, okay. Same like that. So this diagram we are calling Venn diagram, representing the sets. So in set, universal set is the bigger set, then the subset we are writing by using circles. Inside circle we can write numbers as the point, dot, okay. Now again we will come to the set operation, okay. Here too many definitions are there, as you know, or we are explained already in detail. So some brief I am giving here. Now set operation, union operation first, okay. Union means we are using the symbol, this U symbol, union, A union B. So you can see the picture here, just identify the picture, okay. We have A set there, we have B set. See, first circle, this is the A set, this is the B set, rectangle one is the universal set. A union B means all the elements of A and B together, okay. It is coming in the all element, both A and B. That means set of all X such that X belongs to A or X belongs to B, okay. Union means, always keep in our mind, union means or symbol, okay. Or in the logic we are using the symbol or symbol, okay, or. So or means either it is coming in X or it is coming to B, okay. X or B, X or Y, first set or second set together, okay. This all we can write A union B. Now there is a rule relation connecting the A union B, number of elements of A union B. Absolute means number of elements. Cardinality of A union B means cardinality of A, number of elements of A, plus number of elements of B minus number of elements of A intersection B. You can write like this is better. You can just note like this, number of elements of A union B. Instead of using absolute symbol, better to use this one. Number of elements of A union B equal number of elements of A plus number of elements of B minus number of elements of A intersection B, okay. So this is the relation connecting the union and intersection we are discussing here. Intersection means, what is the meaning? Common elements. Using this symbol, down symbol like this, intersection means X belongs to A and X belongs to B. That means X should be a member of A, should be a member of B. You can see the shaded area. See, this is the A set, this is the B set. What is the common area? This green color area, correct. So X should be in A and X should be in B, both. That is the meaning of intersection, okay. So I will show here, intersection means this symbol, meaning is and. X should be, that number should be in the first set and the second set, and, okay. Or in logic we can use this symbol and symbol. Now you can see, if A and B are disjoint set, A intersection B should be phi, empty. For example, you can see one set is here, one set is here. What is the intersection of these two sets? Nothing, not intersecting, correct. So A intersection B, how we can write? A intersection B equal to phi. The first set is A, second set is B. There is no intersection, there is no common portion. If you are drawing Like this means there is one common portion. This is the common intersection portion, correct? But here in the first figure there is no intersection. So intersection is empty. We can say empty set. Okay. So these type of set A and B we are calling a special name disjoint set. Disjoint. Okay. Disjoint set. Hope you understood. Now difference. Difference means subtraction, minus. A minus B set. What is the meaning? A minus B set. Okay. A minus B means set of all x. X should be in A member, A set. And x should not be in B set. Only the numbers from A set, see the green color, should not be in B set because B set is starting from here. Correct? These numbers don't take. Only write the numbers in the A set. Okay. But it should not be in the B set. That means if you are writing, see, this is A, this is B, correct? Now, how we are writing A minus B set? Only take A, okay? A is up to here, but we need to delete the B portion from there. B portion delete, this portion delete. So, what is the answer you are getting? This portion, this is A minus B set. Hope you understood this portion, correct? A minus B set. So this is the difference of two set. A minus B equals set of all x belongs to A. Always the answer should be from the set A. X belongs to the A set, the first set. But x should be doesn't belongs to the B set. Okay. Now there is a relation connecting the difference matrix. Number of elements of A minus B. The cardinality of A minus B equals cardinality of A minus cardinality of A intersection B. So you need to memorize this rule, cardinality rule. Okay, so I can write here. Okay, we can study like this. Number of elements of A minus B. Cardinality of A minus B equals number of elements of A minus number of elements of A intersection B. Number of elements of A minus number of elements of A intersection B. See, this is the meaning of difference of two set. So I hope you understood these three operation: union, intersection and difference. Now we will go to the another operation, complement operation. What is the meaning of complement of two set? For example, complement of a set we are representing either A dash or A bar or A complement, like this. One of the symbol we can use, but better in common we can use this symbol, A dash symbol, A dash. Okay, so A dash equal to A dash, or we can use A bar also. A dash equal to set of all x. X should be in the universal set, but x doesn't belongs to the A set. So complement means actually not in A. That is the meaning. Okay, I will write here A dash means the number not in A, but where it will be there? It should be, that number should be in universal set. Okay, it should be in universal set, but it should not be in A. That is the condition. Okay, for example, you can see A set I am not highlighted. All other numbers, see here, whatever the number here coming, only we write. A coming numbers don't write. That is the meaning complement of a set. Okay, now symmetric difference. What is the meaning? Symmetric difference of a difference of two sets. Symmetric difference, we are using this symbol, put a circle like plus symbol inside. Okay, calling it as symmetric difference of two sets. What is the meaning? You can see set of all x such that x should be in A union B, and x should not be in A intersection B. That means this intersection portion delete. Take all other portion. Intersection portion don't take this portion. Okay, and all other portion, that means here you need to take, here you need to take. Should be in A union B, but should not be in A intersection B. That is the meaning symmetric difference of two sets. So I hope you understood this all five operation. Now we can see one example here. For example here, okay, I will show in another page here. For example, here is the A set, here is the B set. Okay, now 1, 2, 3, 4, 5, 6 are the number. 1, 2, 3, 4, 5 and 6. Correct? This is the first set A, This is the second set B. Now, for example, if you are asking the question A union B, what will be the answer? A union B means all the number, correct? What are the numbers in A? What are the numbers in B? All the number. What are the numbers here? A means 1, 2, 3 and 4, correct? What are the numbers in B here? B equals 3, 4, 5 and 6. Hope you understood. Okay, now what is A union B? All the number together. 1, 2, 3, 4, 5 and 6. No need to repeat the number, write only one time. 1, 2, 3, 4, 5, 6. 3 coming 2 times, 4 coming 2 times. But no need to repeat, write one time. A union B. Now A intersection B. What is the meaning? A intersection B? Common numbers, correct? What are the numbers common? See, 3 number both, 4 number common. So what is the intersection? 3, 4. That means the number coming here 3, 4. This is the intersection. Now next what we need to do is, we have the one universal set here. Universal set is given in the question 1, 2, 3 up to 10. Okay, universal set means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now next one we need to do, what is A minus B? Difference of two set, A minus B. That means from A set delete B numbers. Okay, from A set delete B number. What is A set here? 1, 2, 3, 4. This is the A set, correct? Delete the B number from here. What are the B number? 3, 4, 5, 6. So 3 is coming here, delete. 4 is coming here, delete that one. So what are the remaining number? 1 and 2. From A, delete B number. What are the numbers coming in B? Delete that numbers from A. Okay, so we can see only this portion, 1 number and 2 number. Now next one we need to do A complement. Okay, A complement or A dash equal to, what is the meaning A complement? Not in A, correct? That number should not be from A set. Okay, but it should be in universal set. So from universal set delete the number from A. What are the A numbers? 1, 2, 3, 4, correct? So 1 delete from universal set, 2 delete, 3 delete, 4 delete. That means the A set. A set completely delete from U. So 1, 2, 3, 4 delete, right? Remaining. So what are the remaining? 5, 6, 7, 8, 9 and 10. This is the A complement set. Hope you understood. Now next we need to write A symmetric difference B. A symmetric difference B equal. How to calculate A symmetric difference B? A symmetric difference B means from A and B delete the common number. Okay, delete the common number, intersection number delete. So what are the common numbers in A and B? You can see here. What are the common numbers in A and B? 3 is common, 4 is common in both set. A and B common number 3 and 4. Delete these two number. What are the remaining? 1 is there, 2 is there, 5 is there, 6 is there. This is we are calling A symmetric difference B. So symmetric difference is easy. Just delete the common number in that set. 3 and 4 are common. Intersection number delete. Write the remaining all numbers 1, 2, 5 and 6. That is the asymmetric difference B set. So I hope you understood this example. All the operation whatever we discussed we did here. Okay, now we will go to the some identities. You can read these identities one by one. Okay, you can just read. Now we will go to some questions from this one. Whatever we discussed now, we did the question. We are doing the questions related to this one. Okay, first one. Suppose that A equal to, this is exercise 3.1, question number 3. 1 and 2 already we did. This is question number 3. Suppose that A equal to set 2, 4, 6. Okay, A set is 2, 4, 6. What is B set? B means set 2, 6. Okay, and what is C set? You know, C equals set 4, 6, 8. And Q is the set 4, 6. Q means 4, comma 6. 4 sets are given, correct? Now what is the question? Determine which among these are subset. Which set is a subset of other set? Okay. Which among is a subset of other set? Represent the answer in symbol. Symbol means which is the subset symbol, you know. The C symbol, correct? Using the symbol represent what are the subset. For example, if I am taking Q set and A set, is it subset? Q is a subset? You can check that one. Is it Q is a subset of A? What are the numbers in Q? 4, 6, correct? Is it a subset of A? What is A set? 2, 4, 6, correct? That means all the number in Q, 4 is here, 6 also here. All the number in Q also a member of A, correct? So we can write Q is a subset of A. This is the first answer. Q subset of A, correct? Q is a subset of A. Now what is the other possibility? You can check it. What set is a subset of other set? For example, B set. B set is a subset of A. B means what is the set? 2, 6, correct? What is A? 2, 4 and 6, correct? Is it subset or not? We can check it, correct? Here 2 is already here, 6 also here, correct? So it is a subset. B is a subset of A. That is the second answer. So Q subset of A, first answer. B subset of A, second answer. Now one more option is there. Can you think what is the third option? Which set is a subset of another set? We can write Q and C, correct? For example, Q 4, 6. Is it a subset of C? Yes. 4, 6, 8, correct? Is it a subset? Yes. Because 4 is a member here. 6 also a member here. So we can use the subset notation, correct? So we have 3 options. You can think about other is not only 3 options. Q subset of A, first option. I can write like Q subset of A, this is first answer, and B subset of A, second answer, B subset of A, and lastly Q subset of C, correct? Q is a subset of C. So these are the 3 subset in that example. Hope you understood. Okay, now we will go to the fourth question. X equal to set 1, 2, 3. X equal to set 1, 2, 3. Find the power set of X. Power set, we discussed power set. Power set of S, correct? Power set of the set X. What is the meaning power set? Set of all subset, correct? So what are the subset of that set? What is the first subset? 5. Empty set is the subset of all the set. What is the next one? Singleton set, one number set. Set 1, set 2 and set 3 is a subset, correct? Then 2 number. What are the 2 number? 1, 2. Then 1, 3. Then 2, 3. Correct? Then what is 3 number set? 1, 2, 3. Same set. So totally how many numbers, how many elements are there? 1, 2, 3, 4, 5, 6, 7 and 8. Correct? We remember, we studied already how many elements are there in the power set. Correct? How we are doing? You can see number of elements of X. What is the number of elements of X? 3. We have 3 number only in this set. So how many elements will be in the power set? 2 power 3. That means 8. 2 power number of elements. That means 8 elements should be in the power set of X. So that is the answer. Power set of X we got. Okay, how many number? We can check like this. 2 power number of elements in this set. So 2 power 3, that is 8 elements. Hope you understood. Okay, now we will go to the next one. Question number 5. X equal to set P, Q, R, S, T and Y equal to P, Q, R, S, T, U, V, W. Find X union Y, X intersection Y, X minus Y, Y minus X. Okay, so we will go to one by one. First x union y. X union means what is the operation I told? All, correct? All the number together, all the elements together. But write one time. First I am writing P number, P, Q, R, S, T. Now second set P, Q, R, S, no need to write again, P, Q, R, S, T. Other numbers write U, V and W together, okay? Both set together we are writing, that is the union. Now intersection, X intersection Y. Intersection means the common elements only, correct? Both set it will be. So P is common, Q is common, R is common, S common and T also common, correct? So what are the elements of the intersection? P, Q, R, S and T. Hope you understood. Only write the common numbers. Now x minus y. What is the meaning? X minus y. Okay. We can write x minus y now. X minus y means how we are writing? Write the elements of x but not in y, that numbers. Okay. So for example P is coming in the y set. Delete that from x. Okay. What are the numbers coming y set? Delete that number from x set. Okay. That means x minus y means element should be from x but it should not be in y. So P number we need to delete. Q number is coming in y, so we can delete from here. R coming here, delete from here. S delete here. T also delete here. U, V, W it is not coming in x, so nothing to do. So what set we are getting when we are deleting x from, okay, x minus y numbers we are deleting from x means what is balance? Only the empty set, correct? Phi set is balance. X minus y is the empty set. Hope you understood that one. It is phi, nothing is there. That means just to check what are the x numbers? P, Q, R, S and T. Okay, check these numbers. Check these numbers. Is it coming in y or not? P is coming or not in y? Yes. So delete. Q is coming on y? Yes. Delete. R is coming on y? Yes. Delete. S is coming or not? Yes. T also coming? Delete. So nothing is there, balance. So empty set. Okay, now y minus x. Calculate y minus x now. What is y minus x? So think about y. P, Q, R, S, T, U, V, W. This is the y set. Okay, y set. Y minus x. Now this number, check it is coming in x or not. Y minus x. Okay, first set is y. So P is coming in x, correct? So delete. Q is also coming in x, delete. R is coming, S coming and T is also coming. You can delete this number. So what is pending? U, V and W. That is the answer. Okay. Those numbers not coming in x means we can take U, V and W. I hope you understood that one. Now we will go to the sixth question. Same model but little difference is there. We can do this one. Question number 6. Let U equal to 1, 2, 3 up to 7. Universal set is 1, 2, 3 up to 7. X means 1, 2, 3. Y means 2, 3, 4, 6. Z means 3, 4, 5. Create a Venn diagram for the above set. You know what is the meaning Venn diagram, correct? Represent the universal set by rectangle, subset by circle, point by dot, correct? Elements by dot, points. Okay, so first I am drawing the universal set here. You can see, so using a rectangle we represented the universal set. Okay, now inside we need to draw the x, y and z. Now before drawing x, y, z, you can see x and y. Is there any number common? Yes. What are the number common? 2, 3. It is coming in both set. Common numbers are there. Y and z. Is there any common number? Y set and z set? Yes. What are the common number? 3 is common in both. 4 is common in both. So y and z also common is there. Now x and z if you are taking, that also common is there, because x 3 coming in z also. So all the set common number is there together. So when you are drawing the circle, no, this inside circle, just intersect like this. Okay, I am using different color better. Just intersect like this one. Now the third one. Okay, so first set we are calling x, this green color. Red color set we are calling the y set, and the third one, okay, blue color, we are using z. Can use the circle notation. Okay, now start the universal set. What are the universal set? 1 2 3 4 5 6 7, correct? So first think about the number 1. Number 1 coming in, what are the sets? Number 1 coming in x and only x, number 1, correct? So in the x set, just write 1. X means this green color, 1. Now 2 coming, what are the sets? That one, it is in x, it is in y. Okay, 2 coming x and y. So x and y intersection portion, mark number 2. X and y intersection portion, mark 2. That means the green and red intersection here, 2 we are marking. Now 3 is coming, what are the set? X it is there, y also there, z also there. All these 3 set, number 3 is coming. So these 3 circle common portion, mark 3. See, here is the common portion. So 3. All these 3 circles are coming that area, write 3. Now 4 is coming in which set? Y set, correct? So mark 4 in y set here, only in y. Sorry, not only in y, coming in y and z. Y and z common portion. Y and z common portion here. This is 4, y and z common portion. Now 5 coming in which set? Only in z. So mark in z number 5, only z set. Now 6 coming in which sets? Y only. So we can write in y set number 6. Now 7 coming where? It is not in x, not in y, not in z. So it is coming in universal set. You can mark here somewhere number 7. Okay, number 7. Not in these 3 subset, but in universal set, number 7. So this diagram we are calling the Venn diagram. Venn diagram representing these sets u and x, y, z, these 3 subset. Okay, now we will go to the next question. Question number B. X union y intersection z. X union y intersection z. What is that? So first write what is x union y. Bracketed term first to do, then intersection second one. Okay, so first we need to write what is x union y here, then intersection z set. Okay, what is x union y? X and y together. X set number and y set number together we are writing. That is the meaning x union y. So what will be that one? 1, 2, 3, 4, 6. X numbers and y number. No need to repeat, one time together. 1, 2, 3, 4, 6. Now intersection z set 3, 4 and 5. Okay. Now what we need to do? These 2 set intersection we need to write the answer. Intersection means the common number. For example, what are the common? 3 is common here and here. 4 is common here and here. Correct? No other number common. So what will be the answer? 3 and 4. Set 3 and 4 is the answer. Hope you understood. Okay, now we will go to question number C. Z complement. Z complement. Okay, Z complement means the number not in Z, but it should be in universal set. Okay, so what is the universal set? 1, 2, 3, 4, 5, 6 and 7. This is the universal set. Correct? Now Z complement means Z number delete from here. What are the number Z numbers? You can see Z numbers is 3, 4 and 5. So these three numbers delete. Those numbers coming in Z delete. So what are the remaining? You can write. What are the remaining? 1, 2, 6 and 7. I hope you understood. Okay. Now question number D. X minus Y intersection Z. So first write what is X set minus, then write what is Y intersection Z set. Then you can write the answer. Got it? Okay. We will go. First X set. What is X set? 1, 2 and 3. Now Y intersection Z. What is the set? Y and Z common numbers. Y and Z common numbers means 3 is common, 4 is common. Correct? Y and Z common. 3 and 4. Now what we need to do? Y minus Z. That means, X minus Y intersection Z. This set subtract from here. That means in the first set, delete this number from here. 3. Delete this number. Okay. Delete that number. 4 is not coming here, so no problem. After that, what are the balance number? Set 1 and 2. So this is the answer. Okay. Only the first set answer should be from here, not from here. Second set, what are the number coming here in the first set? Delete that number. That only the idea. Okay, because answer from here only 1, 2, 3, that first set. So from the first set, what you do, that common number delete. 3 number is common, that delete. So remaining is the answer. 1, 2 is the answer. So that is the meaning subtraction. Okay, now we will go to the question number E. X union Y minus Z. So first write what is X set. X is 1, 2, 3. Union Y minus Z set. Y minus Z. Y set, delete Z numbers. So Y set is what? 2, 3, 4, 6. Correct? Delete the Z number. That means the common number. See, 3 is common here. Delete that number. 4 is common here. Delete that number. So what will be the balance? 2 and 6. Got it? Second number, whatever elements balance, no problem. First number, first set, what is the balance? Okay. So 2 and 6. Now take the union of these two. Together write. Together 1, 2, 3 and 6. 2 is coming 2 times, but only write 1. That is 1, 2, 3, 6. Hope you understood. Now X symmetric difference Y. X symmetric difference Y. What is the X set? 1, 2, 3. Symmetric difference Y. What is the Y set? 2, 3, 4 and 6. Okay. Now what you do for symmetric difference? Delete the common number, these two. For example, what are the common numbers is coming? 2 common, 3 also common. Delete this number. This one, delete. Write all other together. Set, what are the other numbers? 1 in the first set, comma, second set 4, comma, 6. So together, okay, together. So symmetric difference means all the number except the common number. All number except the common number. That is the meaning symmetric difference. So 1, 4 and 6. Hope you understood this question, correct? Okay, now let me go to the another question. This one. X union Y cardinality 12. That means number of elements of X union Y means 12. Correct? Number of X equal to 9. Number of elements of X equal to 9. Number of Y equal to 7. Cardinality of Y equal to 7. You can use absolute symbol or this symbol. What is our question? Number of elements of X intersection Y equal to how much? Okay, we studied one rule, relation connecting union and intersection. Remember all of you, n of X union Y, A union B. That means X union Y equal to number of elements of X plus number of elements of Y minus number of elements of X intersection Y. This is the rule. Now apply whatever the number given. Number of X union Y means what is the number? 12 equal number of x, that means 9, plus number of y, that means 7, minus number of x intersection y, that we need to calculate, number of x intersection y. Now we can simplify, that is 12 equal to 9 plus 7, that is 16, minus number of x intersection y, correct? Now you can simplify, you will get answer. Better minus number of x intersection y take to the left side, so it become number of x intersection y, that minus will go, equals 16, we can write here 16 minus 12 going to next side, minus 12, 16 minus 12, that means 4. So what is the answer? Number of x intersection y equal to 4 here. Hope you understood the question. Okay, now let me go to the another definition, then we will continue the exercise. Cartesian product, okay, Cartesian product of two sets and Cartesian product of three sets. For example, A and B are two sets. Cartesian product of two sets A and B are denoted by A cross B. We are using which symbol? Cartesian product. Two set means A cross B, this symbol, okay, A cross B symbol, Cartesian product of A and B. What is the meaning of Cartesian product of A and B? Equal set of all A comma B. A belongs to the first set and B belongs to the second set. First number should be from the first, second number should be from the second set. Set of all ordered pair. Write all the ordered pair. That is the Cartesian product of A and B. Two number set, two sets. For example, A equal to set AB, B equal to set 1, 2, 3. Okay, A equal to set A comma B and B equal to set 1, 2, 3. Correct? How many elements are there to A set? Number of elements of A means 2. Correct? How many elements in B? Number of elements of B means it is 3. Okay, now I am just going to calculate what is A cross B. A cross B, Cartesian product of A and B equal, how to write? Set of all should be ordered pair. Two set means ordered pair. How we are writing? Take the first number here, A, comma, take the first number here, 1. Okay, first number from first set, second number from the second set. Now, comma, what is the other possibility? Same A, take the second number from here, that is 2. Comma, same A, take the third number here, that is 3. After that, go to the B number here. So, B, comma, the first number here, 1. B, comma, 1. Then B, comma, second number 2. Then B, comma, the third number is 3. This collection, okay, first number from first set, second number from the second set, like that we need to write all the possibilities, all the ordered pair. This is what we are calling A cross B, or Cartesian product or cross product of two sets, A cross B. How many elements are there in A cross B? You can see how many elements are coming. How many elements are there? This is the one element, correct? This is 2, this is 3, this is 4, this is 5, and this is 6. So how many elements? How we are finding? Number of elements of A means 2. Number of elements of B means 3. Okay, if you multiply these two, you will get number of elements of A cross B. That means number of elements of A cross B means number of elements of A multiply number of elements of B. Number of elements of A means 2. Multiply number of elements of B means 3. So totally how many get? 6 numbers getting. Okay, so A1, that is the first number, A2 second number, A3 third number, B1, B2, B3, that are the 6 numbers totally. Hope you understood the question A cross B. Now one more example you can see. For example, A equal to set AB, B equal to set 0, 1, 2, C equal to set M. Find the Cartesian product of A, B and C. Now how to do that one? Start from the first set A. First number here, first number here. Okay, all the possibility we need to check. So first A0M. Now again A same, take here 1. So A1, here only one number M. Then A, take this number 2, A2M. After that go to the second number here B. So B0M, B1M and B2M. So how many elements totally? 6 elements. How we will get a 6 number? Because number of elements of A multiply number of elements of B multiply number of elements of C. Correct? What is number of elements of A means 2. Multiply number of elements of B means 3. Number of elements of C means 1. So 2 multiply 3 multiply 1 means 6. Totally 6 number you will get here. So this is the Cartesian product of two sets. I hope you understood this one. Okay, now let me do one example continuing the exercise. Question number 8. Okay, question number 8. So find x cross y, that is the question. Find x cross y. So we will do that one. X cross y equal to set of all. X cross y means ordered pair. 3 set means ordered triple. 2 set means ordered pair. So take the first number here A, comma, first number here 0, comma. Now second number, same A, here second number, that is 3. Then ordered pair, same A, here third number. So A, comma 9. Hope you understood. Then go to B now. Here B. So first number B, first number here 0. Then B, comma 3. Then B, comma 9. Correct? After that go to C. Same way go to the C number, third number. Write in order so that it will not confuse. C, comma 0, C, comma 3, ordered pair, comma C, comma 9. Correct? 9. So this is the x cross y. X cross y equal to. Now how many number calculating? Number of elements of x cross y means how to calculate? Number of elements of x multiply number of elements of y. Correct? How many elements in x set? 3. Multiply how many elements in y set? 3. So how many elements in x cross y? 9 elements. 9 elements. So we got the 9 elements here. Correct? 1, 2, 3, next to 3, next to 3. So 6 plus 3, 9. 9 elements we got. So this is the x cross y. Now we will go to the 9th question in exercise 3.1. Find x cross y cross z. 3 sets are there. X cross y cross z. X cross y cross z equals. So it is not ordered pair, ordered triad, ordered triple. 3 number will be there. So we will start this one. X set first number 10. Y set first number 1. Z set first number, that is 3. Now what is will be next? X set first number 10 same. Y set second number 11. Z set only one number, that is 3. Same number. Understood? We will check all the possibility. Okay, number we need to change each set. Now, comma. Now go to the number 20. Second number. So 20 here. Now second set we are taking 1. Third set of course it is 3 only. Comma. Now first set again 20. Second set 11. Third set 3. Any other possibility? No. So how many possibility will come? Number of elements of x cross y cross z. How we calculate? Number of elements of x multiply number of elements of y multiply number of elements of z. How many elements in x set? 2. Multiply how many elements in y set? 2. Multiply how many elements in z set? That is 1. So totally 2 multiply 1 means 4. So 4 elements we will get it. Correct? That is the cross product of 3 set, X cross Y cross Z set. Okay, now we will go to the last point here in this section, that is the computer representation. Computer representation of a set. Computer representation of a set. Now, how the computer will represent a set, that is the idea here. So, for example, U is the universal set, A1, A2, A3 up to AN. Numbers are not given, just generally A1, A2, A3 up to AN. Subset of universal set is A. A is a subset of universal set, can be represented by a string 1 if that number belongs to the A set, 0 if that number doesn't belongs to the A set. This is the rule for the computer representation. For example, you can see, for example, 1 to 10, this is the universal set. Okay, 1 to 10, that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, correct? This is the U set, universal set. Now, when we are representing universal set in bits, okay, computer representation, what we do now, universal set always computer representing all bit will be 1, because all the number present, that is the meaning 1 bit we are using 9, 10. See, this is the universal set in the string of the bits. String of the bit means 10 bit. See, more than 1 bit, 2 bit, 3 bit, 4 bit, like that. This is the string of the bit. So universal set always complete 1. Empty set, for example, 5 set. Empty set, how it will be there? Nothing is there, correct? So complete 0. This is empty. 0, 0, 0, 0, 0, 0, correct? This is the empty set always representing in computer like 0 bit. Now, in between, we need to write some subset by using bit string. For example, here, A is a subset of odd numbers in U. Only take the odd numbers in U. Write the bit string representing A. Okay. So, what are the odd numbers in universal set? 1 is the odd number, 3 and 5, 7, 9. These are the odd numbers in the bit string. Correct? Now what you do, this set we need to represent by using bit 1 and 0, binary, correct? Using the bit string represent this subset A. So how to write that one? You can see 1, 3, 5, 7, 9. I can show here. See, for example, here I will show to you. Yeah. So I am writing the odd numbers. Okay, odd number set. How can we represent the bit string? For example, 1. 1 is an odd number, correct? So put the binary number 1. Odd number means binary number 1. Odd number means, you know what are the set? 1, 3, 5, 7 and 9. These are the odd number. See, these number position you put 1. All other position put 0. That is the meaning. For example, 2. 2 is an odd number. So 0. 3. 3 is an odd number. Put 1. 4. 4 is an even number. So put 0. 5 is an odd number, put 1. 6, odd number, 7, sorry, 6 is even number, 0. 7, odd number, 1. 8 is an even number, put 0. 9, odd number, put 1. 10 is an even number, put 0. So this is the representation, bit string representation of the subset 1, 3, 5, 7, 9. Okay. So that number, odd number position, put 1. Okay, what are the number in that set? That position you put 1, other position put 0. So this is what is written here. See, 1 position we put 1 bit, 2 is even number 0, 3 is odd number put 1, 4 is even 0, 5 odd, 6 even, 7 odd, 8 even, 9 odd, 10 even. So what are the odd number? Put 1, other position 0 in universal set. Okay. Now, for example, another example, B is a subset of even number. What are the even number in U? 2, 4, 6, 8, 10. Correct? Only in U, universal set. 2, 4, 6, 8, 10. So the bit string representation of the B is 1 position 0 because 1 is odd number. We need only even. 2 position put 1. 3 position 0. 4th position 1, 5th 0, 6th 1, 7th position 0, 8 1, 9 0, 10th position 1. Wherever even number coming, put 1 bit. Okay, so that is the representation of the subset B, that is the even number set. Hope you understood the computer representation of a number. We will go to the some examples. Before that, you can see other operations also by using bit string. For example, C is the subset of the numbers in U. Maximum value 5. Okay, maximum value 5 at a maximum value, with a maximum value of 5. Maximum 5 you can take. So what is that set? 1, 2, 3, 4 up to 5. Okay, our universal set means up to 10. Up to 10, U equal to 1, 2, 3, 4, 5 up to 10. But here in this question, C is a subset of numbers with maximum value 5. So up to 5 you can take 1, 2, 3, 4, 5. Now how we are writing this 1, 2, 3, 4, 5 in bit string? You can see 1 position 1, 2th position 1, 3rd position 1, 4th position 1, 5th position 1. All other position 0. 6, 7, 8, 9, 10. These position we are writing 0. So that is the bit string representation of the set C. Okay. Now you can see some operations here now. Complement operation, union operation and intersection operation, symmetric difference, subtraction, these operation you can see in the table. Okay. For example, bit string C is 1 1 1 1 0 0 0 0 like that. C complement means C dash, okay, or C bar like that. C complement. If 1 coming, complement means 0. 1 means complement 0. Just opposite. 1 complement 0. 1 complement 0. 1 complement 0. 0th complement means opposite 1. 0 complement 1. 0 complement 1. 0 complement, it is 1. Hope you understood, correct? So what is this set actually? 1 number not present, 2 number not present, 3 number no, 4 is no, 5 no, 6 no, 7 no, sorry, before we have 5 no, 6 we have number, 7 we have number, 8 we have number, 9 we have number, 10 we have number, because 1 position. So what is this set? 6, 7, 8, 9, 10. C complement of the set C. Okay, complement of the set C. C means this is the set 1, 2, 3, 4, 5, that's set. Okay, now A and C, what is the union? A and C union. See, A means 1 0 1 0 1 0 1 0 1 0. Bit string of C means 1 1 1 1. You can see this table. Now A union C means union. Union means one of the set, if it is coming, it will come in the union. So here 1 and here 1 means it is 1. One of the number 1 means we can write 1. Okay, like this. See, it is 1. I can show to you that one. For example, first I told complement, a complement. Complement means 1 complement 0, 0 complement 1. So this is the complement operation. Now I want to tell the union. A union B, how it will come. So A union B means 1 union 1. 1 or 1 means it is 1. Now 1 or 0 means 1. 0 or 1 means 1. Okay, 0 or 0 means 0. This is the union operation. Okay, keep in our mind A union. Union means in logic we are using this notation or notation. So 1 or 1 means 1. 1 or 0 means 1. 0 or 1 means 1. 0 or 0 means 0. You can see this table. See, 1 or 1 1. 0 or 1 1. 1 or 1 1. 0 or 1 1. 1 or 1 1. 0 or 0 means only 0. It is coming 0. So 1 of the number 1 means it should be 1. That is the meaning union. Now when we are going intersection, okay, I can show you intersection. A intersection B. Okay, intersection means, for example, in logic we are using this symbol, and symbol, and symbol. Okay, so 1 and 1 means it should be in the intersection. 1 A1 means that number is in A set, B1 means that number is in B set. So both set it is coming means intersection also it will come. That is the meaning 1 or 1 equal to 1. 1 or 0 means 0. Correct? If it not coming both, intersection it will not come. 0 or 1 means it will be 0. 0 or 0 means that also become 0 because both set not present. So intersection also it will not be there. So this is the operation, intersection operation or operation. Okay. Now you can see this table. See A intersection C. 1 or 1 means 1. 0 or 1 means 0. 1 or 1 means 1. Now you can see 0 or 0 means 0. Okay. So keep in your mind that operation. Now A minus C. A minus C. So A minus C when you are seeing, see where is the answer coming is, if A number 1, okay, A number 1 and B number 0 means answer will be 1. Okay, that means it should be in the first set, should not be in the second set. That is the meaning. A number 1, B number 0. For example, A number 1, B number also 1 means it will not be there in A minus C set. Same way 0 minus 1, it is 0. Okay, it is not in the A set. So very easy that one. A minus B defining is easy. I will show here A minus B. For example, 1 minus 1. Okay, so what will be the answer getting? 1 minus 1. It will not be in the A minus B set, 0. Just you can subtraction like that thing, 1 minus 1, 0. Now 1 minus 0 means what will be the answer? 1. And 0 minus 1 means you can think about 0. Okay, because 0 minus 1 minus 1. Minus 1 is not binary. Like that also you can think in short way 0. Now 0 minus 0 also become 0. So this is the minus operation. A minus B operation. Hope you understood. A complement. One more time I will tell. A complement means not in A. Correct? Union means and. Union means or. And intersection means and. Okay. Minus means like this. Now what is the next operation we need to do is symmetric difference. A symmetric difference C. Okay. A symmetric difference C. What it will come, see, at least one number 1. For example, here or here, 0, 1, 1. Okay. At least one number. See, 0, 1. It is 1. Okay. 1, 0. Also 1. Okay. Other case it will be 0. For example, 1, 1. Both 1 means answer 0. Both 0 means answer is 0. That is the meaning B symmetric difference C or symmetric difference operation. So we can write that one. For example, symmetric difference A and B. Okay. So the same thing, same idea we can discuss. 1 and 1, 0. 1 symmetric difference 1 means 0. 0 symmetric difference 0 means 0. All other case 1. 1 symmetric difference 0 means 1 and 0 symmetric difference 1 means 1. So this is the idea in the symmetric difference. So that all table we can conclude like this. Okay, this idea just remember the operations, various operations. Okay, now we will go to the questions. This question, U equal to set 1, 2, 3 up to 10. Universal set is 1, 2, 3 up to 10. Write the bit string. This is the question. Write the bit string that represent the following set. Write the bit string represents the following set. Okay, what is the first set? 1, 3, 6, 10. What is the bit string representing this one? 1, 3, 6, 10. So first you can see universal set. How many numbers are there in universal set? 10 numbers, correct? What are the numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct? 10 number. Now, out of this 10 number, what are the number present in our set? This set. What are the numbers? 1. 1 present. So, instead of 1, you can put binary number 1. 3. Instead of 3, you can put 1. 6. 6th position, you can put 1. 10th position, you can put 1. All other position, 0. So, 2th position, 0. 4, 0. 5, 0. 7, 8, 9, 0. So, this is the bit string representing set 1, 3, 6, 10. Set 1, 3, 6, 10 means this is the bit string representing that set. Okay. Now let me go to the second one. 2, 3, 4, 7, 8, 9. So first I am writing the universal set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because this is the universal set, main set. Now this set how we are representing by using bit string. Okay. So let me start. 1, 2 present. So 2 position put 1. 3 present put 1. 4 present we can put 1. 7, 8, 9. 7, 8, 9. All other position 0. So here 0, 0, 0, 0. That means these numbers are absent in that set. Okay. So that is the bit string represent the set 2, 3, 4, 7, 8, 9. Okay. Now C. We can go to the question C. First I am writing universal set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me do 3. 3 is present. You can put here 1. 4, 10. 4 and 10. All other positions 0. 0, 0, 0, 0. That numbers are not present, absent. So this is the bit string represent that set. I hope you understood the bit string meaning. Okay, now we did here now. Now if you are getting bit string, how can we write the set? That is the next question. Now here we got the set. From the set we are written bit string. Now if you got bit string, how to write the set, original set? Okay, we will go to this question. For example, universal set 1 to 10. Universal set is 1 to 10. What is the question? Determine the set. We need to find the set which represent this bit string 0, 1, 0, 1, 1, 1, 0, 0, 0. Correct? Okay. So let me do that one. First mark the universal set here. First number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct? So what is that set now you can tell. 1th position 0. So 1 number not included. 2 number is 1. Correct? 2 number position binary number is 1. So 2 is included. So 2. 3rd position 0. 4th position 1. So 4. 5th position 1. So 5. 6th position 1. 7th position 1. 8, 0, 9, 0, 10, 0. So this is the set. 2, 4, 5, 6 and 7. Okay. Only remember that 1 bit coming positions. That number you can write. That numbers in the universal set you can write. Okay. Now let me do this one. 1, 2, 3, 4, 5 and 6 absent. 7, 8, 9, 10 present. So what will be the set? 1 is there. 2, 3 and 4. 5, 6 absent. 5, 6 not present. Then 7, 8, 9 and 10 present. So this is the subset of that universal set representing that bit string. Now here what are the number present? First number is there, last number is there, 10. All other absent, correct? So what is the set? 1 and 10. Hope you understood this idea, how to write the set from the bit string. Okay, now let me go to the next question. Let A and B are subsets of universal set. Let A and B are subsets of the universal set 1 to 6. Determine the set A union B, A intersection B, A minus B, A symmetric difference B, and A complement, A dash. Okay. So one by one we will do. For example, A part. A part we need to do A union B set. Correct. So bit string of A is given 0, 1, 1, 0, 0, 0. Bit string of B is given 0, 0, 1, 1, 1 and 0. What is A union B? Union means the symbol or, correct, or symbol, A or B. Okay, A or B, either A1 or B1, that is the meaning. So 0, 0, what is the meaning 0 or 0? 0. We already discussed this table, all of you remember this or table, this one. See, 1 or 1 means 1. 1 or 0 means 1. 0 or 1 means 1. 0, 0, only 0. So we can write the answer here. 1, 0, 1. 1, 1, 1. 0, 1, 1. 0, 1, 1. 0, 0 means 0. Okay. Now we need to write the answer. Answer we need to be in set. So what will be that set? First number absent. Correct? 0. So 1 is not there. Second number present, so 2 is there. Check the universal set. What is the universal set? 1, 2, 3, 4, 5, 6. Correct? Now what is the bit string? Now we got 0, 1, 1, 1, 1, 0. That means this number not present, this number not present, all other number present. So what will be the set? 2, 3, 4, and 5. So this is the union A union B, 2, 3, 4 and 5. Okay, hope you understood. Go to the second one now. Bit string of A 0, 1, 1, 0, 0, 0. Bit string of B is given. What is A intersection B? A and B. Intersection means A and B. What is the rule we have studied? A and B, you can see first. A and B, here you can see intersection rule. 1 and 1, only 1. All other 0. Both 1 coming 1. All other case 0. That is the meaning A intersection B, A and B. So we can go to that one. See, for example, 0 and 0, 0. 1 and 0, 0. 1 and 1, 1. 0 and 1, 0. 0 and 1, 0. 0, 0, 0. So what will be the set here? We are writing only one number present. Correct? Out of the number 1, 2, 3, 4, 5, 6. What is the bit string here? 0, 0, 1, 0, 0, 0. Only this number present. What is that number? 3. Correct? So we can write the answer. Set 3 is the intersection. Set 3 is the intersection. Okay, now let me start the part C. Okay, you can see the part C now. So part C, bit string of A 0, 1, 1, 0, 0 and bit string of B is given. What is A minus B? That is part C, A minus B. So before coming to the A minus B, you can see what is the minus operation here. A minus B, 1 and 1 means like 0. Just like subtraction you can do, easy to understand like this. 1 minus 0, 1, 0 minus 1, 0, 0 minus 0 is 0. So we can go to this question now. A minus B. For example, 0 minus 0, 0. 1 minus 0, 1. 1 minus 1, 0. 0 minus 1, 0. 0 minus 1, 0. 0 minus 0, that is 0. Correct? So only one number in A minus B. So we can write what is that number. What is the universal set? 1, 2, 3, 4, 5 and 6. Now what is the bit string we got now? 0, 1, 0, 0, 0 and 0. Correct? Now out of this one, you can see out of this one which number is present? Only number 2 present. All other number 0 absent. Here no, this number no, this number no, this number no. So only number 2 is the answer. So we can write that answer. This set A minus B means set 2. A minus B means set 2. Okay, now let me go to the asymmetric difference B. Asymmetric difference B. Okay, D. So before coming to symmetric difference operation, you can see what is asymmetric difference B. One symmetric difference 1 means it is 0. Okay, 0 symmetric difference 0 means 0. All other it is 1. 1 symmetric difference 0, 1. 0 symmetric difference 1, 1. Both 1, 0. Both 0, 0. So we can go this question now. Both 0, it becomes 0. 1, 0, it is 1. Both 1, it becomes 0. 0, 1 means it becomes 1. And 0, 1, it becomes 1. 0, 0, becomes 0. Correct? Now we are writing the answer. What number present? You can see universal set is 1, 2, 3, 4, 5 and 6. What are the numbers present? You can see by bit string 0, 1, 0, 1, 1 and 0. So 1 number not present, 2 is present, 3 not there, 4 present, 5 present, 6 is not there. So we can write the answer now here. The answer becomes asymmetric difference B means set 2 is there, 4 is there and 5. 2, 4 and 5. That is the symmetric difference A and B. Hope you understood the symmetric difference. Now A complement. What is the meaning? Complement of a set. Complement means just opposite. For example, 0 complement 1. 1 complement 0. 1 complement 0. 0 complement 1. 0 complement 1. 0 complement here also 1. So we can write the answer here. What will be the answer? Number 1 present. Number 2 0. Correct? This is number, I can show here. This is number 1, 2, 3, 4, 5 and 6. So what are the number present? 1 is present, 2 no, 3 also no, 4 present, 5 present and 6 present. So this is the complement of the set A. So I hope you understood this operation, how we are calculating A intersection A minus B and A symmetric difference B and A complement of the set. So we will go to the next question now. Question number 13. Up to question 12, it was the computer representation that questions. Now question number 13. Now we are going to do some word problems. Okay, some wordings will be there. From that we need to answer the question. Each question we need to answer. For example, question number 13. You can read the question. In a school there are 20 teachers who teaches mathematics or physics. Okay, so mathematics teaching teachers I am representing M. M means those teachers that are teaching mathematics. Okay, and P means those teachers teaching physics. Okay, physics teachers I am representing P. So 20 teachers who teaches mathematics or physics. You can see that word or. Or means what is the meaning? Union. Keep in your mind, or means union. So mathematics or physics teaching teachers number is 20. So how can we write that one? We can write number of the teachers mathematics or means union, physics, that means 20. Hope you understood. Number of the teachers mathematics or means union, P physics equal to 20. Now read again. Of these 12 teachers teach mathematics. Okay, 12 teachers teach mathematics. So number of teachers teaching mathematics equal to 12. Okay, now again read. And 4 teachers teach both physics and mathematics. Both. And means what is the symbol we are using for and? And means intersection. And means intersection. Okay, so 4 teachers teach both physics and mathematics. So number of teachers mathematics and means intersection physics equal to 4. Number of teachers teaching mathematics and physics. Now what is the question? How many teach physics? That means number of teachers teaching physics equal to how much? This is the question. Number of teachers who teach physics equal to how much? So this is the question. I hope you understood the question. Now I am going to answer the question now. We studied one rule, relation connecting union and intersection. What was that rule? Number of A union B. Here instead of A, here M. Instead of B, here P. Mathematics and physics, correct? So number of M union P equals number of elements of M plus number of elements of P minus number of elements of M intersection P, correct? You remember that rule, I hope. We studied like this, number of A union B equal to number of A plus number of B minus number of A intersection B. Okay, this was the rule we have studied this section. But here instead of A, you can use the mathematics teacher. B means the physics teacher. Okay, that change will be there. Okay, now you can see the numbers one by one. Okay, number of M union P, what is that? 20. It's given in the question. 20 equal this number. Number of M, number of mathematics teachers, 12 plus number of physics teacher, we don't know, we need to calculate number of physics minus number of mathematics and physics intersection, that is 4, correct? Now simplify so that you will get the answer. So 20 equals 12 minus 4, 8 plus number of P, number of physics, correct? 12 minus 4, correct? That is 8. Now number of P, keep it to one side. Number of elements of P equal plus 8 take to next side. 20 minus 8, that means 12. Number of P physics teachers equal to 12. Number of teachers who is teaching physics is 12. I hope you understood this question. Okay, now let me go to the next question. Question number 14. Okay, question number 14 here. You can read the question correctly so that you will understood the content. So in a class, I am just reading here, in a class 35 students are there. 24 likes to play cricket, 16 likes to play football. Also each student likes to play at least one of these two games. So these 35 students, they will play at least one of these games. Sometime they are playing cricket or football, like that. How many students will like to play both cricket and football? That is the question. How many they will play both cricket and football? Okay, so let me see that one. For example, I am representing C as cricket. Okay, and F I am representing as football. Okay, now you can read one by one. Okay, from the beginning. In a class 35 students. 35 students means all the students number telling. So number of the cricket or football is equal to 35. Because a class, all the students either they are playing football or cricket. Correct? All the students. So total students means football players and cricket players together. How much totally? Equal to 35. That is why number of cricket union football equal to 35. Okay. Now 24 likes to play cricket. So number of students playing cricket equal to 24. Now 16 play only football. So number of players playing football equal to 16. Okay. Now what is the question? How many students likes to play both cricket and means intersection, correct? Here it is coming, intersection. So what is the question we need to do? Number of the students, those who are playing both cricket and football. Cricket and means intersection. Football. C intersection F equal to how much? Number of students that playing both cricket and football. And means intersection. So again we are writing the same rule. Whatever we are used just before. Number of A union B equals. A union B means here which letters we are using instead of A and B. A means we can use C. Union B means F. So C union F equals number of cricket plus number of football minus number of both C intersection F. Okay, minus number of C intersection F. Now apply the numbers. What are the numbers given here? Number of C union F is there, 35, equal number of cricket is there, correct, 24, plus number of football players 16 minus number of C intersection F we don't know, we need to calculate that one, correct. Now you can add here, simplify, you will get the answer. So 35 equals, you can see 24 plus 16, that means 40, plus minus number of C intersection F. Now simplify, you can take minus number of C intersection F, we can take to next side so that you can delete that negative sign. Number of C intersection F equals 40, we can write 40 plus 35, go to the next side, minus 35. 40 minus 35 means 5. That is the number of the students that who plays both cricket and football. Both playing numbers, that is 5. Hope you understood the question. Okay, now let me go to the last question, question number 15. Assume that, you can read the question first. Assume that out of 1000 students, 200 are enrolled in math classes, okay, and 300 are enrolled in physics classes. 50 are enrolled in both, okay, 50 are enrolled in both classes. So what is the condition here? For example, math, I am representing M, mathematics M, and physics I am representing by using P, physics enrolled students. Okay, so some students they are enrolled in math courses, okay, and some students are enrolled in physics courses, some are enrolled both, correct, like that. So we can read from here, 200 are enrolled in math classes. So number of students enrolled in math classes equal to 200. Now 300 are enrolled in physics. Number of students enrolled in physics equal to 300, correct. Now 50 enrolled both means they are enrolled in physics and math, both means it is intersection, okay, keep in your mind, intersection. So number of M intersection P equal to 50, equal to 50. Hope you understood. Now what is the meaning this 1000? Assume that 1000 student, 1000 means a universal set, the complete students, okay, universal set. So I am writing here number of elements of the universal set equal to 1000, okay, because why we are taking that universal set? Because here only we are telling about math and physics, we are not telling about other courses, okay. So some students maybe they will take another courses, not math and physics, other courses also will be there. So that is why that is universal set, okay. Before question you remember, before question when we are telling each student play at least one of the game, 2 games. So all the student one of the game they are playing, cricket or football, like that. That is why we are not taken here universal set. Now here when we are taking here math and physics enrolled students only we are telling here. Okay, other courses enrolled students we are not telling. So keep in your mind, that is the universal set, number of U equal to 1000. Now we are going to answer the first part of the question, but first try to understand the question. First question, what is the meaning? A part of the question, how many individuals, okay, enrolled at least one of these classes, that means either math or physics, that is the meaning at least, either math or physics, that is the meaning at least one of the courses. Okay, minimum one course they should enroll, either math or physics. So what is the meaning? That one, number of the students, math or physics, or means union, equal to how much? This is the first question. Okay, either or means whenever you are seeing or, at least means union P. Now what is the second part of the question? B part of the question, you can see, how many students have decided not to enroll any of these courses? Not. Okay, that means not enrolled in A or B, that is the meaning, not enrolled any of these two courses, math and physics, not enrolled. So how to write one? Not means complement. Okay, not means complement, not A or B, they are not enrolling. So what is the meaning? Number of the students enrolled, A or means union, B complement, correct? A or B not means complement. This number equal to how much? This is the second question. Now what is the third question? C part of the question. C part means how many students enrolled only in math? They can take only math, A only possible. What we need to do? We need to subtract B. We don't want B, correct? A only we needed means B subtract from A. That means number of A minus B. A means I am telling here, A means the math, subtract physics students from that one. That means math minus P. From enrolled students, math enrolled students, subtract physics enrolled student from that one. Because some students they are studying both math and physics. We need only math student, correct? So math minus physics, how much? Number of. These are the question here we need to do. I hope you understood the question. Okay, you can read one or two times so that it will come in your mind. So I am answering this question now. Okay, so first part, A part of the question. What is the A part of the question? Number of M union P equal to how much? So we are starting from the rule first, correct? Number of M union P equals number of M plus number of P minus number of M intersection P, correct? Now you can see what are the number here in the question you can apply. Number of mathematics 200 plus number of physics 300 minus number of M intersection P, mathematics intersection P means 50. Okay, so that you will get the answer here, number of M union P, that means 300 plus 200, that is 500 minus 50, that means 450. Hope it is clear to you. Now B part of the question. What is the B part of the question? Number of A union B complement. Number of A union B complement equals. How to do that one? Number of A union B complement. For example, this is the universal set. Okay, universal set, full set. For example, this is the A union B. A union B. Okay. Now A union B complement, that means not in A union B, that means this portion. How we are calculating this portion? A union B complement portion. Simply you can apply your logic. Number of universal set minus number of A union B. That is the meaning, number of A union B complement, correct? The complete part delete the union part, A union B part, so that you will get it this part, this shaded part, number of A union B complement. Okay, so what will be the answer? You can check now. Number of number of universal set, how much? 1000. 1000 minus number of A union B just before we calculated. A union B means M union P. Keep in your mind, M union P. I am using A and B. So keep in your mind it is M and P. Mathematics and physics, M union P. Okay. In figure also, instead of A and B, I am writing here M union P. Okay. So we can go to the answer now. What is number of M union P? In A part we have 450. So totally what will be the answer? You can check it. 1000 minus 450 means 550. Clear? Okay. Now let me go to the C part of the question. What is the C part? We need to do number of M minus P, correct? Number of M minus P equal to how much? We studied one rule in the beginning itself. Number of A minus B, like we are studied number of elements of A minus B. We studied one rule equals number of elements of A minus number of elements of A intersection B, correct? We studied only mainly two rules. One is number of A union B rule, that is number of A plus number of B minus number of A intersection B, correct? This is the second rule. Number of A minus B equals number of A minus number of A intersection B. Now instead of A, here we are using M, mathematics. B, we are using physics. So how to write this rule? You can see number of M minus P equals number of students in M minus number of students in M intersection P. Now you can check the answer. What is number of students in mathematics? 200. 200 minus number of M intersection P. Both mathematics and physics. How many students? 50. So 200 minus 50. So how many we will get? 200 minus 50 means 150, 150. So this is number of M minus P we are getting. So I hope you understood this question. So this is little lengthy module, lengthy section, as you know. Many ideas we have studied. What is the meaning set? What are the different operations in set? And we studied the types of the set classification, and cross product we have studied, Cartesian product of two sets, and bit string, computer representation of the set we have studied, and lastly some word problems also we solved here. So I hope you understood this recorded class. So thank you for watching. Please subscribe my channel for getting more recorded classes. Thank you very much.